Something extraordinary is unfolding in our solar system, and the newest update about 3I Atlas might be the strangest anomaly yet. On November 23rd, Avi Loeb revealed what he is calling the 13th anomaly of this object, and this one is all about mathematical precision that should be physically impossible for any natural comet. Right now, 3I Atlas is heading toward Jupiter, approaching for a close pass on March 16, 2026. That's less than 4 months from now. Astronomers have been tracking its path using data from over 230 observatories feeding into NASA's Jet Propulsion Laboratory system. And according to that data, 3I Atlas will pass Jupiter at a distance of about 33 million miles. To understand why that number matters, you first need to know about something called Jupiter's Hill radius. Think of it as Jupiter's invisible gravitational bubble. Inside that radius, Jupiter's gravity dominates and is strong enough to capture objects into orbit. Outside of it, the Sun's gravity takes over again and pulls everything back toward the inner solar system. The Hill radius isn't some vague estimate. It's calculated using extremely precise physics involving Jupiter's mass, the Sun's mass, and the distance between them at that exact moment in time. NASA calculated that on March 16th, the Hill radius will be about 33.24 million miles. Now here's the part that shocked everyone. NASA's trajectory prediction says 3I Atlas will pass Jupiter at 33.21 million miles. The difference between these numbers is only about 35,000 miles, out of 33 million. To put this into perspective, imagine standing on one end of a football field, blindfolded, throwing a dart, and hitting within 0.1% of the bullseye. What 3I Atlas is doing is even more precise. Statistically, the probability of this happening at random is 0.004%. About once every 26,000 tries. But the situation becomes even more unbelievable when you factor in another detail. 3I Atlas has been showing non-gravitational acceleration. This means the object is not following a purely gravitational path. Something else is pushing it. Jets, forces, or something we don't understand. Scientists measured this acceleration at 5 times 10 to the minus 7th astronomical units per day squared. In simple terms, the object has been speeding up or redirecting itself in a way that can't be explained by the Sun, Jupiter, or any other known gravitational force. This non-gravitational acceleration shifted 3I Atlas's trajectory by around 62,000 miles. Almost exactly the amount needed to guide it from where it was naturally heading into a path that threads the needle right at Jupiter's Hill radius. And that raises the big question. Why is the Hill radius so important? Because right at the boundary of that Hill sphere are special gravitational zones called Lagrange points. These are areas in space where gravity from two bodies, like Jupiter and the Sun, balance out almost perfectly. If you want to park a satellite using as little fuel as possible, you put it at a Lagrange point. We use these points all the time. The James Webb Space Telescope sits at the Earth-Sun L2 point for exactly this reason. It's stable, efficient, and requires almost no fuel to maintain its position. Now think about the implication. 3I Atlas is arriving at exactly the distance where you would want to deploy satellites around Jupiter if you were trying to minimize energy use. And it reached this point after exhibiting what looks suspiciously like a course correction. Scientists are now examining 4 possible explanations. The first is that our trajectory calculations might be wrong. Maybe the path will shift as better data comes in. Maybe some gravitational factor hasn't been accounted for. But NASA's JPL Horizon system has been tracking 3I Atlas with incredible precision using hundreds of observatories. Even allowing for a margin of error, about 61,000 miles, the hill radius alignment still holds. The second possibility is natural comet outgassing. Jets of gas could have pushed 3I Atlas in exactly the right direction. We know it experienced non-gravitational acceleration near the Sun, so maybe the jets just happened to fire in the perfect configuration. The problem? Natural outgassing is chaotic. Ice pockets explode unpredictably. Comets rotate irregularly. Getting a 62,000-mile course adjustment that perfectly targets the hill radius would require precision that nature simply doesn't produce. The third explanation, supported by about 70% of scientists, is that this is pure coincidence. Over billions of years, countless interstellar objects pass through the solar system. Eventually, one of them might randomly hit an extremely specific target. But Avi Loeb points out the flaw in that reasoning. We've only detected 3 interstellar objects in history. For the third one to immediately hit a 1 in 26,000 statistical event is like winning the lottery on your third ticket. Possible, sure. Likely? Not at all. And finally, there is the fourth explanation, the one Avi Loeb is entertaining, that 3I Atlas has some form of propulsion or controlled movement that deliberately guided it toward Jupiter's hill radius. Maybe to deploy something. Maybe to use Jupiter's gravity for a maneuver. Maybe for purposes we cannot guess. The problem is that we have no direct evidence. No radio signals, no heat signatures, no obvious propulsion. All we have are the numbers. A statistically impossible alignment, and a measured acceleration in precisely the correct direction. Scientists, of course, repeat the golden rule. Extraordinary claims require extraordinary evidence. But regardless of the explanation, each possibility is groundbreaking.